Okay. All right, so I'm just going to finish up the examples. So example 4 is that bad boy. So 1, 2, 3, 4. So y not equal to 0 and true. Okay, same. This example is similar to the previous example, except we use and in the expression just like the previous example, both sides evaluate to true. But remember, I guess we might as well put this in. But remember that, geez, the previous example, the logical or short-circuited before evaluating the truth statement on the right-hand side. Here, however, we also have to evaluate the right-hand side, which is true. Therefore, this whole expression becomes true. Yeah, I didn't really have to go over these explanations because I just get the feeling they may be a bit terse, not detailed enough maybe. So not is equal to x. Okay. Example 5. In this example, we use 2 logical operators, the not and the logical and. The logical not is evaluated first, which flips the x variable from true to false. Then I should actually say we evaluate the left-hand side first. Then within the left-hand side expression, the logical not has precedence and is evaluated first. Let me correct my spelling. The logical not has precedence. Clearly precedence, note to self, nothing but ease. The logical not has precedence and is evaluated first, which flips the x variable from true to false. Then we test the equality using the double equals. Yeah, and then false. Then we test the equality using the double equals, which results in false since the not x is false and the x is true, therefore they are not equal. Finally, we short circuit out of this expression, since it is a logical AND, which requires both sides of the expression to be true. And I probably won't go into more detail. I was going to compound some more logical operators. So we know this is true. And let's add an AND in here. I can actually maybe do that. Just to not get too gross, but it is gross. It is, there's a bit going on in that final. Yes. So finally, in example 6, 1, 2, 3, 4, 5. Yeah, example 6. This example is a bit more, bit is such a horrible word, but yeah, this example is a bit more complex than the previous examples, since there are two different, I shouldn't even say two different, it's the first time we encountered two binary logical operators, not unary, which is the not, but two binary logical operators. The logical or and also a logical and. So let's evaluate from left to right. I knew I needed an apostrophe. I know that. will fix it for me. I almost want Google Docs to autocorrect. And they should actually autocorrect and actually put like a blue squiggly or something under it to say, yeah, we autocorrected it, but it's a blue squiggly, so maybe you should just double check that we didn't screw that up. Yeah, whatever. Okay. So let's evaluate from left to right. 10 is not less than W, but it is equal to W. Therefore, the leftmost relational expression is true. Probably need a hyphen. Let's see what it says. I think leftmost would probably make sense hyphenated, wouldn't it? Doesn't matter because this is just what I'm reading, but whatever. Okay, therefore the leftmost relational expression is true, right? So what I'm getting at is that is true. Okay. Where did I do that? Wow, I went way down here. Okay. Oh, geez. Did I paste that? Darn it. X. Good. Now let's look at the right-hand side of the logical OR, which is y is greater than or equal to 5 floats. So again, the same holds true. This evaluates to true since 5.0f is equal to y. Okay. Okay. Now I want to talk about, so then we just did that one logical expression, that logical OR expression, and it evaluated to true. I should actually test the short circuiting on Y. I might do that. I might do this in code, but it could be a bit, yeah. At this, you know, like we could prove that this portion gets short-circuited because really all we need to do is a value, and I actually should say that in the comments, is we know that this is true. Therefore, this expression just results as a true, and we just short circuit into the not x. Yeah. So, you know what? I got to get rid of these other examples. Okay. Which is, okay. Now let's look at the right-hand side of the logical OR. However, you may be asking yourself, I don't want to come off as too cheesy, and that does. But I like the intent of that sentence. However, you may be asking yourself, wouldn't a short circuit happen where, oh no, happen since the left-hand side resulted in true? This is correct. Thanks for asking. What means return 0? Oh, you mean at the end of a Stranky's? Do you mean at the end of like your main method? Like if you did something like this, int main, like in your function? Is that what you mean? If that's what you mean, it's typically, it's a carry forward from C, which is an error code. And the loader or your operating system will load the executable, and the loader will sometimes behave based on that error code. So any non-zero value is considered to be an error code. 0 is considered to be successful execution of your executable program. So typically you'll return 0 on all of your main methods, which is your typical entry point in any executable program. However, if you do encounter some sort of error, you may want to return a non-zero number that would represent that error, but I don't know. Yeah. I think that's what you're getting at. So 0 means no error. However, you may be asking yourself, won't a short circuit happen? Wouldn't a short circuit happen since the left-hand side result in true? This is correct. Perfect. This is correct. And the whole expression of 10 less than or equal to W or Y is greater than or equal to 5F float becomes true. Okay, so now that we know the expressions on the left-hand side of our logical and are true, we are left with true and not X. Geez, that one's getting a bit complex. I should almost add like animations in the slide where you kind of hit the key and it shows you it changing. And I probably should do that. I probably should take the next 30 minutes to probably do that on all these examples. So as I'm reading them out loud to people, they can see how it's evaluating things. That makes sense. That would really enhance this slide. Okay, I'm going to actually do that. Okay, but anyway, I'll finish off this last example, then I'll add the animations in the slide. So true and not X. How do I untab? It's like Shift tab doesn't work. Oh, there we go. This is just delete. I thought I did. Okay. Right. And which evaluates to false since the right-hand side of this expression results in false, or flipping the, no, I'm just going to leave it at that. Okay, yeah, so I'm going to do some animation on this bad boy. I just lost my laptop. Okay, hold on here. Okay. Okay, so what do I want to do here? I want to, okay, I want to do the animation. So instead of these comments on the side of my examples, I'm going to turf that, and I'm going to, yeah, I'm going to actually use animations. Okay. Okay. So how do I want to do this? I want to, this kind of sucks because now each one of these has to be its own chunk of text. Each one of these bad boys has to be its own chunk of text. So I'll leave this one as the master. Okay, I think I know what I'm doing here. It looks kind of hokey, but bear with me. Okay. So, copy V. Okay, good. So here we go. So okay, so how do I do animations? How do I do my animation? Tools, insert animation, perfect. On click. Okay, so I want to animate this guy. No, not you, this guy. Fade in on click. Brilliant. Let's just play that. Cool. So the slide, you can see my copy and paste stuff on the side. And then I click and I get to see, I'll just turn, okay, good. Yeah, I'm happy with that. Stop. Yeah. I've got two animations doing the same thing. Okay, and I'm going to copy and paste that sucker. I wonder if I even want a C out. Well, I'll leave it. I will leave that. So this is and he'll fade out. And then this guy we can evaluate. So X is true. And oh, this is so messy. And W greater than Y is true. It gets a bit greasy doing these animations, especially when there's going to be a lot of animation examples. So if I run this, oh, I didn't want that. Oh, that's horrible. That's really bad. Maybe I should do the 2 parts. Control Z. It's like, yeah, good for you. I kind of approached this the wrong way. Oh, this stupid line here is just causing me grief. Okay, so example 1. Oh my goodness. Holy God. Holy. Okay. I wonder if I should, I probably could do this. Could probably drop this sucker right in the middle. Okay, cool. Yeah, I kind of made a bit of a mess out of this, but oh, you know, this kind of screws up my example wording that I did too, because I'm thinking, you know, I'll just go left to right. So X becomes true. And then we'll do the right-hand side, which is W is greater, yeah, and that's true. And I think we're smart enough to figure it out. So this guy fades in. This guy fades out. And then this guy and this guy add animation. He fades in and he fades out. So let's just run this, see how it looks. And maybe I will do one more, which is just true. And you know what? I'm going to have to turf those C outs because I think it just gets confusing. And then let's just say true. So I will highlight, add animation, fade in him, fade out you. Cool. A bit painful, but that is how it works. So if we play this, okay, so there's our first example as we evaluate through. That didn't disappear. Okay, I want to try this one more time. This is driving me crazy. Okay, I'm going to present the slide. I'm going to actually see it in real action. So we know X is true. Then we evaluate the right-hand side. Oh, lovely. It is borked. And it's kind of all, it's messy. Okay. So I should align them by the bottom. Didn't really help me. I'd actually like to make all these text boxes the same size. I guess once I get at least this group of animation done, I just copy it and I can just redo it for the next example. So hopefully it won't be as tedious. There's a way to align left. I thought there was a way to make them the same size. I thought yeah. Fade out, fade out. I'm gonna have a run at this again here. Oh, that was slow. Here's what I'll do. Forget the fade out. Straight up disappear. I think the problem is no seconds. Just go away. Super fast. Super fast. Okay, let's try that. That looks all right. Sorta. I mean, it should be more, I think, aligned in the middle. However, I can do that at a later point. I can... I almost wish I could make a group. Oh, this guy's driving me crazy. I'm selling a boat, and I put it really low because I'm sick and tired of it. I just want it gone. And now I've got it on Kijiji. I've got it on eBay. And it's just crazy. People are like desperate to get it. I don't know if you guys ever use Kijiji. It's just the biggest nightmare in the world. People like constantly questions and tire kickers, and they don't buy it. But they certainly like to waste your time. Okay, shit though. You know what? I got to go through each one of these. It's like, I wish I could ugh, it's so painful doing animations. So painful. Okay, so wonder if I can order these horizontally or vertically. No, I just want to distribute them vertically. Didn't work. How do I increase it? Ooh, that actually worked. Cool. Well, I know the top guy is our last guy, so I can click on him and move him down. Then this guy. Then this guy. And this is our... So the next example was this. I'm going to pop this a little closer. So the next example was not x and w is less than 50. So we can go not x and w is less than a literal. A literal. So not x is false. I don't think we cover the short circuit on example 2. I think in 3 it was, yeah. Okay, well, whatever. So false. So w is greater than 50, false. And finally false. So those are all of the steps in this. Fade in dude on click. Disappear fast. And add an animation. Fade in on click. Disappear fast. Add an animation, fade in on click, disappear super fast. Cool. So let's play all this. Am I playing? What the hell? I guess that's still showing. I'll have to look at that. Now that and that. That's not right. Okay, I gotta stop that. It's a little bit messed up, the animation here. Okay, what's going on? So we fade in. And who the heck disappears? Well, we really should be I want him highlighted and him highlighted. Oh, man. Okay, let's look at what I'm doing here. That's fine. Fade in. I don't know why he would need to disappear. Fades in. I really borked this animation. I'm just going to turf all these animations. I hate doing animations. I had another slide that was crazy earlier last week. And it's just a nightmare. I might have went a bit too far. Okay. So this guy and these guys, so let's add an animation for this. Fade in, and all of these guys can just simply disappear. Whether they were displayed or not. I think most of them would have disappeared, but with previous, disappear. Disappear. Why is you fade in? Super fast. Cool. Let's just play this to make sure we got at least the first step done. Actually, that's probably right. So that guy disappeared, all those guys. So I'll click on him, add an animation, fade in, disappear. And add an animation, fade in, disappear. And then last but not least, fade in, and you can disappear. Okay. Yeah, it worked. Good. I'm happy. Okay, so I need to munge these guys up a bit. Left. Tops. Oh. Arrange, align, top. And I wonder if I should just arrange them all. Arrange, align, top, and left. They look a little hokey. Okay, so now let's do y not equal to 0, literal, or true. Step 2. Y is not equal to 0 and true is true. Therefore, we are true. So let us highlight all that stuff. This guy, oh, I do him first and then I do those. Add animation, fade in on click, and can I highlight? No. There must be a way to default this. Slide's gonna have so many animations. It's probably crash once it's done. Okay. So let's run this whole mess. Those guys shouldn't even show. Great. Or did I even do the whole thing? Let us look. Oh yeah, so I just disappeared. Okay, that's okay. I was wrong. Add animation, fade in, and disappear fast. This, and finally this. Add animation, fade in, disappear fast. Cool. Okay, so now we've got this guy. Y not equal to 0 and true. Oop. Copy, paste. And then we know we evaluate left to right. Y is 5. And it's not 0, so that is true. And then we'll copy this one more time and do our final evaluation, which is true. So time to do our animation magic. I need to highlight him first, then shift highlight them, then add an animation. He fades in. All of these guys disappear. Slides take forever. And I'm sure the way I'm doing it doesn't help, but they do take a long time. But I'm looking forward to getting this done, because this can be applied to pretty much any course I want to do. So I guess short-term pain, long-term gain. Fast. And finally this and this. Add an animation. He disappears. Okay. So that is done. That fall shouldn't be so far over. Good. I'm starting to feel a little more confident in my animation skills. Okay, so now we've got not x is equal to x, and y is equal to 5.0f, I believe. Sweet. Okay. So left to right, we know it's a false. I really probably should include the short circuiting so that it sticks with people. I'd have to go and do all my slides again. But actually, in a way, I wouldn't. Where I evaluated it, I can just keep that animation, but instead of evaluating it to a Boolean, a truth, I could just have the animation, instead of show it evaluated, I could just have it crossed out. Yeah, why not? Why not? How do I cross out strike? Strike. Cool. Yeah, you know what? That's what I'm going to do. That way I don't have to change too much in my animations. That'll work. Okay, we're done with that guy. I will copy, shift copy, add an animation, and deal with the pain of setting every single one of these. I know there's a better way of doing this. I mean, this by paragraph maybe would be helpful, but each one is its own text field, so I don't know if that would work. I just don't want to muck with it. I'm this far in. I think I'll just leave it. There was some, well, there is a company out there, a website called Envato Marketplace that sells like, if you build video games, you can buy like sprite sheets and graphics and assets, sound effects, music, videos, 3D models. And I looked on there, and they sell a lot of slides actually. And they look really good. Like pre-done templates and slide decks ready for you to just do your thing with. So, oh, I missed a couple. Or did I? Let's just see. Yeah, I did. Let's stop. So that was that. I'm actually still going to do this to this, add animation, fade in, disappear fast. And now this to this guy. Disappear fast. I will quickly run this just to make sure it's in line with what I want. Yay. Looks good. I'll probably move all of those guys into a kind of more in the center. It looks a little unaligned. Okay, left, top. And I will copy one of these guys, paste them, move them down, and do my thing. Okay, so we've got 10 less than or equal to W, or Y is greater than or equal to 5 and not X. Make a copy. Let's work left to right. 10 is less than or equal to 10. True. And we short circuit this. So I guess I can strike through this. Anybody who's out there, you probably know relational and logical operators like nobody's business now. So now we're left with this and this, and we can do it here, not X, false, and finally a false. Cool. So short circuit. Cool. Okay. Click, highlight, add an animation. You know what I'm going to do? I'm going to put on some music. I'm going mental. Sound, cloud, non-copyright sounds. They must have more than this. There we go. I gotta mute this. I'm gonna get feedback on. Just gotta plug in my headphones. My apologies if that sound is really loud. I'm just gonna tweak. It's a little bit loud, I think. Yeah, doesn't sound good either. I just want some sort of monotonous, take me out of this mindset. Okay, cool. Awesome. So this guy fades in. All of these bad boys have to disappear. this guy. Oh, that wasn't right. What's the speed on this? 1 second. Okay, now this dude and this dude, add animation, fade in. Disappear. Super fast. I think that's good. Let's try it out. Yay, 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 yeah, yeah, yeah. There was a false down here, right? Yeah. I guess it's off the slides, so it makes sense. All right. I'm a little bit concerned. I'm going to do this. I know this group, life is good, so I'm going to keep them over here. Now, these guys, I should have done that. Now I got to arrange them and distribute them vertically, I believe. I mean, I guess I can take one. And then maybe distribute vertically. Okay. Now I kind of made life difficult for myself. So we know the first example we had was I just made life so hard. This is just a freaking mess. Like, I guess I can tell. I just need to know the order of these guys. So I can do it. Actually, this might save me. I mean, I did a stupid mistake. But so that's the first dude. X and W greater than Y. So we can click on the next animation. So this is the next slide. So, yeah, true. So there's no short circuiting here. The next slide is true and true. So there's no short circuit on that. Let me get these guys out of here, though, as a group. I know you're there. Oh, you stay. Control Z. Oh, my God. They're so tight together. I can't. Fuck. All right, get over there. I really made life hard on myself doing all, yeah, whatever. Okay. So, okay. So, dude, you're first. then you, highlight you, right in the middle, right in the middle. Okay. I know you guys are probably like, what the hell is this guy doing? But yeah, it's probably a true statement. What the hell am I doing? And finally, this is the evaluation. Cool. But at least now, I can highlight all of them. Oh, you were so close. Cool. So now if I arrange these guys together, lefty, toppy, good. Now I can get these dudes out of the way. So we know I've short-circuited those guys as a group. Okay. So we know we did this as a short circuit. So let's look at not X. Okay. This is example 2. So this is example 2. Here's the second slide. I just want to highlight you, man. Okay, so not. So as soon as we know that's a not, I need to short circuit this slide. And that's the result. Cool. Oh, what did I do? Control Z that one. Arrange, thought I did. Lefties. Tops. Cool. Okay. Y not equal to 0 or true. Cool. Good. So I'm going to drag him there, and then I'm going to find the next slide here. But we would just short circuit this, and even though it's true, I'm going to actually show it as short circuited. And that's the result. Okay, we're getting almost done. Thank goodness. I'll leave them there. And true, so he's next. This is the next related slide. And there's no short circuiting going on here. Cool. This is good. Finally, I feel good. It's finally getting done. Okay, so not X is equal to X, and okay, cool. So we got this guy. Where's his buddy? Cool, we did the short circuit. And whoever you are. Okay, so if I highlight them, I'm gonna try to do this and unselect him. Cool. So now I can arrange them all together. on, move. I'll try to align them more in the middle, I think is probably a smarter move. Ooh, that's great. Thanks. Let's see where the snaps. The snap's telling me that's right in the middle. Might as well fill up some of the space here. I'll do this. Okay, I'm going to try. Okay, so let's play this. Let's see how the animations work and the examples work. Okay, so given blah, example 1, and we work our way through. So the left-hand side is true. And then the right-hand side is true, and then it evaluates true. Good. Second example, left-hand side false. Right hand side true, but yeah, short circuit and false. Y is not, that's true, left hand side, therefore we short circuit and we get true. Same as last, except we have a logical and instead of a logical or. True, no short circuit, and it should evaluate to true. Good. First, the not X gets evaluated. Ooh. Can I go back? Okay, so this is where I've got a bit of borkness. I got to fix this. So, true and true. Oh, wait. But we shorts... No. What? Where was I? Okay, wait a minute. Right here. So, we should have... false is equal to true. Yeah. Goodness, I don't even know if that's the right shit. Fuck. Oh, I made such a mistake on that one. Fudge. So I am looking for this dude. Where is he in the grand scheme of things here? So I'm going to move him out because you're messed up. You're next. How is he? I guess so. It wasn't bad. It's just I jumped a step. I don't want to put in another slide, another text field. That'll just screw everything up. Well, that's life. false is equal to true. So obviously that's false. And y is equal to and we short-circuited that prematurely, so we'll unstrike through. Now the only issue is I need to somehow stick in another text field. So I copy, paste, oh man, this is so messy. Oh, I don't know if I can even do that. Oh, fuck. I'm so disappointed. And I give up. I know it's gonna look a bit cheese, but them's the breaks. I just don't. I can't deal with this.
Your car is new and reliable, but sometimes your memory is not. So you ran out of gas on your way to a big client meeting. But luckily, you didn't forget your AMA membership. Join now for less than $9 a month.
I'm just gonna say false. It's just not cool. Not cool. Okay, whatever. Is what it is. Middle seems to work the best. Okay, I'm gonna actually present this slide. Let's see what it looks like. False and short circuit and false. Y not equal to 0, true, and short circuit to true and true. Y not equal to 0, true. True and true is true. Not y is equal to x, false. Oh. Oh yeah, that's good. So we get the not x evaluates first. So false is equal to x, which is false. And we short circuit. So that's where I kind of hacked that slide. So 10 is less than or equal to w. So that's true. And we short circuit, leaving us with true on the left-hand side and not. Yep. And then true becomes false, and it becomes a false statement. Cool. I mean, it's not ideal, but it'll do. Cool. So if I present this, I thought I could present this and show the slide notes. Oh, here we go. Because I might be able to change these while I'm actually looking through it. I'm hoping. I'm hoping. Nah, I can't. It's frozen. Okay, I gotta move the notes on another slide. I'll read it aloud as I'm doing it. Example 1. The first combined expression is x and w is greater than y. This results in a true. See, yeah, the explanations suck. It just isn't going with the flow. Okay, well, I'm going to update those notes a little later because I don't want to see this slide anymore. Okay. Flow of control. So let's cover our if conditionals and switch conditional even, and our while, do while, for loop, ranged for loop. Okay, so clearly conditional statements. So far we've touched upon our common conditional statement in C++, the if statements. I think we did. Conditionals are vital in any programming language, and C++ is no exception. For example, in a game, we may need to decide if a player is successful in defeating an enemy by checking the enemy's hit points, by checking if the enemy's hit points fall below 0. Great. This example is best done using an if statement in our C++ program. Fair enough. An if statement in C++ can also have the alternative path called the else statement. Which the C++ program will execute when the if statement evaluates to false. Can also have the optional, because it is optional, alternative, can have the optional alternative path. Looks like an M, but it's an R and an N together. Wow, lovely. Okay, this is an important section, and we'll work through examples and demos to help understand conditional statements, looping, and functions. Sweetheart? What? You don't need anything. This section will cover... Okay, this is an important section. We'll work through examples and demos to help understand conditional statements, looping, and functions. This section we will... Yeah, but... Yeah, this is an important section. I'm going to strike that out for now. This section we will cover flow of control in C++. This includes more than just conditional statements. It will also include looping statements and functions. So far in this course, all the C++ code we have done executes statements from the top down, one after another in sequential order. However, more complex programs require the ability to make decisions using conditional statements like the if statement. They may require iterating using loops to allow code to repeat a finite amount of times, or they may be cases where you will need to call functions, which are reusable chunks of code that typically perform a specific action. Sounds good. This is especially true when building video games, where you will loop continuously while the game is running. And in that loop, you'll be drawing, calculating, handling collisions, and also handling user input. I'm going to strike that through. And also handling user input on each frame of the game. For example, you may have a game where a player needs to defeat all the enemies before the game ends. To do this, you would have a loop that would continuously check to see if the player's bullets hit an enemy, and also check to see if all the enemies are defeated. Once this game over condition of all the enemies defeated is met, then the game ends. Once the game over condition of all the enemies defeated is met, then the game ends. This is elegantly handled by looping continuously and checking specific conditions. That's not too bad. Let's go ahead and first look at our conditional statements. Hold on a sec. Come here, honey. Come on. Over there. Girl. Come on. Over on your bed. On your bed. Over there. What? Okay, so how do we write a conditional statement in C++? Well, we use the C++ keyword if, as you can see in this slide. If statements will begin with the keyword followed by an expression that evaluates to true or false. If the Boolean expression or antecedent includes variables, including variables, evaluates to true, then the code within the if statement's code block will get executed. Note that it is also possible to exclude the curly braces. In this case, a statement directly after the if statement will execute, as shown in the second example on the slide. If statement examples. Looking at the first example, the if statement is basically checking if all enemies in the game are eliminated. If this is true, we will set the value of the variable called uWin to true. This example has a code block defined by the opening and closing curly braces. And all statements within this code block will execute, assuming the if statement evaluates to true. In the second example, we declare an int variable that stores the player's hit points. If the player's hit points are 0 or less, then the if statement, if the player's hit points are 0 or less, the if statement will evaluate to true. In this example, we just execute the first statement after the ifs. In this example, we just execute the first statement after the if statement. In this second, I just don't want to confuse it. In this second example, which doesn't contain curly braces or a code block, we just execute the first statement after the if statement. The major difference between the first example and the second example is the second example is missing the code block. This is perfectly valid. However, when the curly braces defining the code block are excluded, only the first statement after the if statement will be executed as part of the if statement. The else clause. Sometimes if your condition is not met, then you might want to perform another block of statements instead. For example, if there are bad guys left, the game continues, else the game is over. We can express that statement using the if then else block in C++. The example in the slide shows how the else clause is used. For example, if the game over variable is set to true, then the game ends. If the game over variable is false, then we instead, let me read that again. If the game over variable is false, we instead execute the statements within the else clause, which in this example, the game just calls a function continue game. Let me read that. It doesn't seem bad, but it does seem bad. If the game over variable is false, we instead execute the statements within the else clause, which in this example, the game just calls. This example, the program I'll use game. Synonymous enough with program. We will look at some examples in a demo in the next slide. Okay, so demo. This is a simple program using the if and else keywords in our if then else statement. I will demo this in Visual Studio, but feel free to program this yourself, then run and compile it. Then compile and run it. This program is very simple, where we simply ask the user for a whole number, and based on the number provided, the program will execute the statements within the if block or the else block. So if it's greater than 0, if the user enters a number larger than 0, the if statement evaluates to true, and the if statement's code block will be executed. If, however, the user enters a number less than or equal to 0, the else condition is true, and the else statement's code block will be executed instead. Let's run this. This program is very simple, where we ask the user for a number. I just don't want to go with whole. I don't want to confuse it. And based on the number provided, the program will execute the statements within the if block or the else block. If the user enters a number larger than 0, the if statement evaluates to true. And if the statement's code block, oh God. Okay, I'm gonna come back to that. That one's really kind of smells. Nested if. We learned how if-else statements can have two conditional paths. Either the if statement will be executed or the else statement will be executed. We may want more than these two conditional paths. There are a couple of options to do this. The first option we will cover is the nested if-else statement. In the example on the slide, our logic is saying that we do not need to evaluate X if W is false. Yeah, that's true. It's just how, I don't know if the wording is great. In the example on the slide, our logic is saying that we do not need to evaluate X if W is false. Yeah, that's true. This example will only evaluate the inner if-else statement when W is true. Yeah, I guess. Once it comes out as a whole, it sounds okay. The inner if-else statement allows us to create more complex conditional logic, and in this case, that logic is predicated on the variable W being true. Yeah, makes sense. More conditional statements. Let's run this demo in Visual Studio. I need to type some text in here. Okay. The for loop down. Oh, and then I think I just went crazy. I hated doing slides. I just started doing demos because I just wanted to code for a while. So I'm going to have to do for loop. Okay, so now I need to do some for loop slides. So what do I got left to do? I've got for loop left to do. I've got functions left to do. I've got while loops, do while loops. The break and continue keywords to cover. Once all that is done, oh, and the switch statements, because that'll be part of our conditional statements, like the if. So once all that is done, then this section is finally done. And I actually was going to do vectors, containers like arrays as well. Whew. Maybe I should move, well, let's look at these demos. So we got a while loop demo. I'll go through the start. So we've got, I actually present it. It's easier to, just trying to get my bearings here where I'm at. Okay, so, right. So we've seen if statements. Why does that... disappears. Whatever. Okay. More conditional statements. So that's fine. Demo for loop. So here we go. So we got to cover our for loop, our ranged for loop, our while loop, our do while loop, the break keyword, obviously, the continue keyword, and then our vector. Yeah, I need to cover that. So I know some of our problems require us to use a container. Functions. This music's annoying now. Functions. Okay, there's a lot to cover. It's just tricky because, like, some of this, I'm just gonna put this down. Yeah, I really want to get all of this out of the way, then I can get into the game. How long have I been streaming for? I may bail. I'm just not up to it today. How long have I been going here? A whopping hour and 40 minutes. Big deal. Okay. Let's go back. So, functions, more functions, variable scope. Holy goodness. Math functions. And then finally putting it all together in this video game, where, so putting it all together. So let me look at Visual Studio. Let's go to where our, I'm sure I did the game. Oh, here we go. Putting it all together. Because depending on what's in this final game project, I may not need to cover functions yet, or containers. However, we do have a function for rolling our dice, so randomly generating a dice roll. we got a function to print out damage to the console window. So I definitely have to cover functions. I may be able to move that vector. Move the vector out. Yeah. Yeah, I think I might move the vector stuff out since we don't really cover it. Whatever. So let's close this. Now I'm going to work my way back. So conditionals, functions, variable scope with functions. Let me see if any of these demos use a container. No container, no container, no container, no container. Definitely a container, however, this just covers a container. No container. Initialization list on this one though, but it's not really a container. You know what? I might move vectors out of here. So let's go back. That's a big section. Holy goodness. So we can turf containers, relational operations, logical, we'll call it operators. Relational, logical, conditional, loops, and functions. Wow, that is crazy. Just for one section to cover that. Ideally, I probably should break up these three into section 2. These guys can go into section 3. So section 3 can be loops, looping, loops, functions, and containers. But that leaves me in a bit of a bind with if I look at these demos. think. Well, I think I'll give it some thought. I'm going to end the stream, and I'm going to start up tomorrow morning. I think we've done enough of these slides. They're driving me crazy, actually. So I think I need a break. 2 streams on this is more than enough for me today. So anyway, I'm going to head out on the stream. Thanks for watching there, guys. I will hopefully see you again tomorrow. Pretty much every weekday I'm on, so I will